we are now moving on to the second half of this unit, which is logarithm. You will see later on today how logarithm and exponents are related. So logarithm means exponent and is another way of writing a power. So this one here, this, you can read this as y equals to log of x, logarithm of x, base 2 with base 2. However, throughout this unit here, I would just read that as y equals to log base 2 of x, or y equals to log base 2x. Okay, so y equals to log base 2x can be expressed as this. These two equations, believe it or not, are the same thing. You'll probably think, what the heck? So before I move on to talk about what's going on here, I would like to do a few examples on basic stuff of logarithm. For those of you who have experience in Chem 20, Chem 30, you are in a little bit of upper hand, because in the acids and bases unit, we talk about how to use the log of the concentration to find the pH or pOH. Anyway, so let's do a few examples. So take out your calculator. So let's do this. Examples here. Log 10. Alright, so go to your calculator. Log is here. Log 10. Close bracket. Doesn't matter if your calculator is in degree mode or radian mode, it has no effect. So log 10 gives you 1. That gives you 1. Alright, let's do another one. Log 100. Log 100. Enter. With or without closing bracket, that's fine. So that gives you 2. Alright, so I don't know if you see a pattern or not. Just let you guys know that when we say log without any specific, without specifying the base, without specifying the base here, then we assume that the base is 10. So like this. So that means you can actually write this as log base 10 and 10. Log base 10 of 10 gives you 1. This one, if you did not see any base, then we assume that's base 10. So log base 10, 100 is 2. Now I don't know if you can see any mathematical relationship. Okay, if not, never mind, I'll show you this. This will definitely help many of you understand logarithm better. Alright, so for 10, can I write that as 10 raised to the power of 1? If you're not sure what this is, you can enter that into your calculator. I'm not going to show that to you. Now this one, 10 to the power of 1 gives you 10. And for 100, can I say 100 is 10 square? Now look at this. Okay, I hope you can start to see a pattern of how things work out for logarithm. I understand that this is just the first lesson. So let's do log base 10, 0.1. If you want, you can take this out. Okay, you won't be marked wrong. However, I'm trying to show you the pattern so that you can see how 10 plays in logarithm here. At least for this type with normal log. So if you do this, 10, so log 0.1, so log 0.1, close bracket, enter. That gives you -1. Now, I hope you can use the pattern that I showed you here and write this. So base 10, base 10, base 10, base 10, base 10, and base 10. What is the exponent? Whatever answer we have. So if you look at this, 10 raised to the power of -1 is actually 0.1. So now I would like you to pause for a few seconds, have a look, and hopefully you can get a basic idea of how things work out for the normal log, which is base 10. Alright, let's do other examples to illustrate the other aspects of logarithm. So let's do eight. Can I say 8 is 2 raised to the power of 3? Of course, yes. Now let's see how logarithm can change things around. Here you have 2 raised to the power of 3. So if you recall the first half of this unit that we just finished, we talked about exponential function. Here the base is 2. So what we are going to do is we are going to take the logarithm on both sides, and because the base is 2 here, so we are going to do log base 2 on each side. Okay, 8, 2 to the third, 8, 2 to the third. Just to avoid confusion, I put the brackets. I'm going to cheat a little bit by showing you something that you'll learn in the near future. So if you have something like this, the base of the log and the base of the exponent, they're the same. So log base 2 of 2 to the power of 3. In this case, this 2 and this 2 here, the base of this log, and then this, the base of the exponent, if they're the same, they would cancel out like this. Okay, so that means we end up with the 3 down here, not as an exponent. And then left hand side, we have log base 2 of 8. So now I hope you can see how logarithm plays here, what it does. So some of you will probably ask me, Cheng, are you sure that if you have something like this, same number, that thing would cancel out? Well, we can do it on your graphing calculator. Let's do this here. So you go to math, go down to this one here, log base, 1 up, enter. Then you can do this. What did we have? Log base 2, 2 to raise to the power of 3. So log base 2, 2 to the power of 3. 3. As I mentioned, if you have the base of the log and the base of the exponent, they're the same, they will cancel out. So this becomes the answer. The exponent becomes the answer. Okay, so hope you are convinced. And I know some of you say, Cheng, I don't have this on my graphing calculator, the thing that you just show us. Math, this one here. If you are using TI-84 plus CE and higher models, you have this option. If not, in the near future, I'll show you how you can do the same thing except in a longer way. You don't have to buy another calculator. This is a minor thing. Okay, so let's go back here. Now, the last example I want to do before I get back to your notes is this. So let's do something like this. Log base 3 of 3 raised to the power 4. What would the answer be? Of course, you can do this on your graphing calculator, but I hope you can figure this out without using your calculator. As I just mentioned, if the base of the log and the base of the exponent, they're the same, then guess what? They would cancel out. I'm not going to write down here, otherwise you would think I changed the question. So these things cancel out, I end up with a 4. Let's do this on your graphing calculator. So let's don't do this normal log. This normal log is base of 10. Alright, so go to math, second last one, the base. So log base 3 of 3 raised to the power of 4. That should give us 4. And bingo, that's 4. On a second thought, maybe I should teach you how to do that for those of you that your graphing calculator doesn't do this either. If it is Casio, I think Casio can do that, but I don't know how, sorry. Right? So, or with a lower TI model, older version, it's not a big deal. So I'm going to check off this one here. Check. Okay, so what does it say? If you have log of base C, so if you have log base B of C, you can write that as log base A of C divided by or over log base A of B. So basically C here, the base is on the bottom. Then what is the base of the log here? In this case, as long as they're the same, it doesn't matter. So here you can do base 10. Alright, so let's see how it works with this, the thing that we just did. So if your graphing calculator doesn't have this handy base function, I mean base of a log, then never mind. Let me use a different color here. So this, let's do it here from scratch. Log base 3 of 3 raised to the power 4. You can write that as log C over log B. So in this case, you would write that as log 3, sorry. So you can write that as log of this on the top and then the base, you just take the log of that on the bottom, log 3. And if you want to be specific, you can say log base 10, which follows the same format of what you see on the formula sheet here. Log of this divided by log of that, and then base 10 for all of them. So quickly do this on your calculator. So log 3 raised to the power 4 divided by log 3, log 3 raised to the power 4 divided by log 3, close bracket, enter. Look at that, same thing. Okay, let's go back here and do this one. Which one do we want to do? If you want, do this. So log base 2 of 2 to the power of 3, that should give you 3. So here, log base 2 of 2 raised to the power of 3 is the same as log 2 raised to the power of 3 divided by log 2. Try this. So just log 2 raised to the power of 3 divided by log 2, close bracket, enter. That's 3, like what we got. Look at that, same thing. So for those of you who don't have a newer model, or who is using the older model of the calculator, it is okay. You just do an extra step to figure things out. Now before we go back to the notes, let's look at this again. So here, this is the example. So for examples ago, so we started with this, blah 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 blah. So what I would like you guys to look at is you can take the base 2 here of the log, move it to the other side, like this. You can take the base 2, move it here, and then make this and turn this into the exponent. Then you have 8 equals to 2 raised to the power of 3, like that. Pause for a few seconds, have a look, because if you can get this straight, the second, this part here for logarithm, it should not be that bad. Now let's look at this, the thing that we did 15 minutes ago. So how can I convert this into this? Well, first thing is I'm going to rewrite this, change the orientation. So instead of saying y equals to log base 2x, I'm going to write log base 2x equals to y. So I'm passing on change technique to you. So if you want to get rid of the log, you move the base of the log to the other side. So this one goes here, which bumps the y into an exponent. So that means x equals to 2 raised to the power of y. Isn't this what we have? Alright, or another way to show you this, which reinforces the stuff that we have done so far in this lesson. Let's do this. So let's take the logarithm of base 2 on both sides. Because look at this, base 2 for this exponent. So let's do this. Log base 2 of x equals to log base 2 of 2 to the y. So if you look at this, we take the logarithm on both sides, so this is mathematically legit. Now if you look at this, remember what I told you guys? Taught you guys the technique. So base 2 of the log, base 2 of the exponent, that cancel out. So that gives you y on this, and then the other side, there's nothing you can do with log base 2x. So look at this, isn't this this? Okay, now if you can ignore this arrow. Okay, so what happens is if you swap these two, remember the inverses from transformation unit. So if you look at this for the inverse, remember the 6 transformations. Sorry, not the 6 transformation, it is something other than the 6 transformation. This is the inverse. You have a mirror image reflected on the y equals to x thing, like this. I'll just do a quick review here. Oops. This is the reflection line. You have a graph here, you have a graph here, something like that. Okay, so the inverse is swapping x and y. So if you swap the x and the y, instead of having x equals to 2 raised to the power of y, you have y equals to 2 raised to the power of x. So this is actually the inverse of this. We'll graph this in a second. Okay, and the last thing I want to mention, which I forgot to do so, we will do this in a second, is the different names of different forms. So let me erase this to clear this. You don't have to erase anything. So if you see a mathematical expression written this way involving logarithm, we call this the logarithmic form because you have the log. So this form here is logarithmic form. This one with the exponent, we call that exponential form, because in the near future you will deal with examples that we ask you to convert this form into that and vice versa. Alright, so now let's work out some examples. So convert to exponential form. So this is the logarithmic form, so let's convert this into exponential form. So that means we don't want the log there. There are two ways you can do that. As you all know my style, I want to show you as many ways as I can so that if one way doesn't make sense, at least the other way hopefully would. Alright, so the first way, you can think of this as a shortcut if you want, which is, in this case, to have the exponential form, we want to get rid of the log. So just like what I showed you before, we can take the base of the log, move it to the other side, which bumps the number of variables, whatever you have, and turn that into an exponent. So after doing this, the log will be gone. So that means 27 equals to 3 raised to the power of n. So this is a shortcut method, nice and easy. Sorry, I lie. There's only one way to do it at this point. I mix up with anything. Okay, so now if you look at the second example here, convert this logarithmic form into exponential form. So basically, you just move the base to the other side and bump that to become an exponent, and then the logarithm will be gone. So after doing that, the left hand side we would just end up with 16 and then right hand side, the base here becomes the base here on the other side, and then the end here becomes the exponent. Okay, so now question 2, let's do the other way around. We want the exponential form to be converted into logarithmic form. So that means we want to have the log somewhere. So remember for the last question, I told you guys that there were two ways to do that. Well, I actually messed up with this. So actually this one has two ways to do that. If you go back here, before I showed you the two ways, one of them is a shortcut again. So if you look at this, you have 27 equals to 3 raised to the power of n. If you take the 3, this space here for this exponent, and move it down here, and then you can convert this into a log. The exponent becomes the answer, or whatever you have on this side. So I'll just leave that here like this. So let's do this. 2 raised to the power of y equals to m. So we're going to do the shortcut method first. So this is the base for the exponent. So if you take this base, move it here as the base of the log, then you still have m, except now we have a log, and this, the base for the exponent, is now the base of the logarithm, and then your exponent is the answer, or at least the answer for this step here. Now you can do it backward. Take a 2, put it here. It bumps the y to become the exponent, and then the log will be gone. You get that? If you're saying, Cheng, this is so confusing, you totally lost me, you know what? First, I don't care. Now, let's do it the long way. So, what you can do is, if this is base 2 of this exponent here, then what we can do is take the logarithm on both sides. What's the base we want? The base here is 2 for the exponent, so for the log we want to have the same base, which is 2. So now just bring everything down here. So log base 2 of y equals to log base 2 of m. As I told you guys before, using something you'll learn in the future, the base of the log and the base of the exponent, they're the same, so that cancel out. What do we end up with? Left hand side just y, and then right hand side there's nothing we can do. Log base 2 of m. Isn't this what we had before? Okay, now try b here. Okay, so second example, I hope you spend some time trying to at least have already attempted this question here. So I'm going to show you 2 methods. First is the shortcut, and then I'll show you the long way like this. Alright, so if you look at this, a raised to the power of t equals to p, so the base of the logarithm here is, sorry, the base of the exponent here is a. So if you take the base of the exponent and turn that into the base of the logarithm, so log base a of p, you can put brackets around if you want, doesn't make any difference. Then the exponent drops and becomes the answer for that side. So here's the answer. Same thing, you can it may take you a little bit while to figure out this, to visualize it, but if you do it backward, take the base a here for the log and then bring it here, it bumps the t into the exponent. So a goes here, it becomes a to the power of t, and then the log will be gone. So, alright, if you're saying again, Cheng, it doesn't make sense, let's do it the long way, so hopefully it would make a bit more sense. Let's erase this, start from scratch, assume we have never done this before. Alright, then this is the base for the exponent, so let's take the logarithm on both sides with base a. So log base a to the power of t, same thing, take the log on the other side, same log base a to the power of p, same base, a for the log, a for the exponent, so that cancel out. What do we end up with? T equals to log base a of p. Isn't this what we had before? Alright? Okay, I can tell, even though I'm not here with you, I can tell you're having so much fun. So, let's do this. Okay, so next one, evaluate the following logarithm. So tell me the value. I'm going to show you 2 ways. One is, of course, by taking advantage of your graphing calculator, but I hope you can figure out this correctly without using a calculator. That shows you your understanding. So let's do this one by graphing. Let's do this algebraically, and then we'll confirm our answer by plugging this into your graphing calculator. So if you look at this, how can we solve this algebraically? Well, first thing is to set it equal to something so that we can solve this. So let's say we set that equals to, you can call this x, you can call this a, you can call this b, or let's call this n. Alright, so I'm going to do the shortcut method here. So if you take the base 4 here and move it to the other side, it bumps the n to become the exponent. So I'll just you don't have to show me this. I'm just helping some of you to visualize this. So the base 4 of the logarithm is now the base of an exponent. So this becomes the exponent. And then this side, after doing that, the log would be gone. So that means you end up with 1 over 64. Then how do we solve this? We turn them into the same base, like what you guys learn near the end of the exponential function stuff. So 1 over 64, you can write that as 4 raised to the power of -3. Okay, you can plug this into your calculator to confirm that it's the same as 1 over 64. Okay, equals to 4 over n. Now we can drop the bases. So that means n is -3. Okay, so that means our answer is -3. So log base 4 of 1 over 64 is -3. So as I said, you don't have to call it n, you can call it a, call it x, call it whatever. Now we can do this on your graphing calculator. So go to math, second last one. So we have log base of 4, and then inside we have 1 divided by 64, enter. That gives you -3. That's what we figured out. So this expression is equal to -3. And I'll show, for those of you who are using an older model, I'll show this to you one last time. Okay, so this formula. So if you look at this, it is the same as log 1 over 64 divided by log 4. So log, oops, I don't need that, 1 divided by 64, close bracket, divided by log 4, enter. Same answer. Okay, let's do several more. I'm not going to do all of them because you should have some fun. Let's do B here. So of course, in this case, for your, since you don't write the diploma exam, for your unit test cumulative, you can cheat, but hopefully you can do this algebraically, which proves your understanding. Well, maybe you should say, can I call it something else? I just don't like n. Well, you can call it x. Okay, so now same thing. Get rid of the log by taking the base of the log, move it to the other side. So move it to the other side. So that means the 2, which is the base of the log, becomes the base of the exponent. So it bumps this x and turn it into an exponent. Right? So after doing that, the log is gone. So you have 1024. So in this case, you might want to try to figure out. So you should have the same base. Obviously, that's not the case. So 2 to the power of what gives you 10,024. So hopefully you figure out that, or you can just keep trying. 2 to the 6, 2 to the 7, 2 to the 8. Okay, 2 raised to the power of 10 gives you 2 to the x. And then we just drop the base because the two bases are the same. That means the exponent must be the same. So that means x is equals to 10. I'll show you guys one last time how to do this on your graphing calculator. Okay, so clear all this. Math, second last option. So we have log base 2 of 1024. Enter. That is 10, and that's what we got. Okay, so I'm going to skip C. You can look at the answers like that I posted on D12, the PDF file, not the video lessons. So I want to do D here. I verbally mentioned this at the beginning of the class today. So have a look. If there's no base stated, the base is 10. We call this a common log. Alright, so if you don't see a base, because if you look at all this, they all have a base, base 2, sorry, base 3, base 4, base 2. So this means there's an invisible number here, which says 10. Of course, you can cheat by using this on your, by plugging this into your graphing calculator. But if you want to do it algebraically, let's do this. So log base 10 100 equals to x. Move this. I'm sure some of this figure this out because 100 is 10 raised to the power of 2, so that the exponent is 2, so that means the answer is 2. Okay, for base 10. Anyway, so after moving the base of the log to the other side, left hand side, you get rid of the log. You got rid of the log already. So the base for the log becomes the base of the exponent, and then this becomes your exponent. And then same idea. So 100 is the same as 10 raised to the power of 2 and 10x. So that means x must be 2. So I am going to do, let's do E here. You can figure out F. You know what? Maybe I should just give you the answer if you're too lazy to blah blah blah. So the answer is 3/2. If you are too busy or too lazy to look at the PDF file for the notes. Anyway, let's do this one here. So again, you can cheat by using your graphing calculator. So I'm not going to show you how to do that. You all should be able to do that. Alright, so if you look at this, again, we set it equal to something so that we can solve for whatever that thing is. Alright, so if you look at this here, same thing, we are going to move the base of the log to the other side to make it the base of the exponent. So do that. So after that, the left hand side, we end up with 81 of the queen root of 81, and then the base 3 of the log becomes the base of the exponent 3 raised to the power of x. Okay, well, at least I can show you this here. Okay, so in this case, it's kind of hard to convert this into base 3, so we have to do something slightly different. So let's rewrite this. So we can write that as 81 raised to the power of 1/5. Okay, equals to 3 raised to the power of x. Alright, so after that, let's convert 81 into the base of 3. So 3 raised to the power of what gives you 81. You can keep trying. So I hope you figure out that 3 raised to the power 4 gives you 81. And then outside that, raised to the power of 1/5 equals to 3 raised to the power of x. And then we can multiply this math 10c stuff. Hope you still remember 4 times 1/5 gives you 3 raised to the power of 4/5 equals to 3 raised to the power of x. If they don't look alike, put the brackets around. Now same base, so that means x is equal to 4/5. Okay, so this one I'm not going to do that, but figure this out. Your answer should be 5/2. Or maybe I should go back here, at least show you how to punch all this in your graphing calculator, because I wouldn't be surprised that some of you may not know how to do this. So now if you do this math, second last function, second last option, so log base 3, and then queen root of 81. So you do math again. So now you want to go to this one, number 5. So it's queen root. What's under the root is 81. Enter. That gives you 0.8. Alright, so you may say, Chang, I don't see why 0.8 is the same as 4/5. So another technique pass on to you. Hopefully this is just a review. So you go to math, pick the first one. That would convert, your calculator would convert whatever decimal you have, of course nice decimal, into a fraction like this. Enter. That gives you 4/5, which is what we had before. Okay,